let's look at some examples of where we have to solve a system, a linear system, with two equations and two variables. To start, let's just review what can happen when we have such a system. We can have two lines that intersect at one point, two lines that overlap, and so they intersect at all the points on both lines. And we could also have parallel lines. When the two lines intersect at one point, we're going to have one solution. When the two lines overlap, we're going to have infinitely many solutions. And when the two lines are parallel, we're going to have no solution. So remember that a solution is a point that lies on both lines. There are three methods that we're going to use to solve a system. The methods are graphing, substitution, and elimination. I'm going to show you each type of method. We're going to use it for these examples. We're also going to talk about the pros and cons of each method. And we're going to discuss when to use a certain method, because when you do these problems, you only want to use one method. So which method should you use? Which one's the best? And then that depends on the problem that you're looking at. So we'll discuss that. So here's our first example. I think we've seen this one before. I actually gave you the solution, but we didn't do anything to find the solution. So that's what we're going to do here. Now I'm going to solve this problem three ways. I'm going to use graphing, substitution, and elimination. That way you can see all the different ways to solve this. I'm also going to do that with the other problems. There's 6 problems in total. And I'm going to alternate which one I do first. And you only have to use one method when you solve this type of problem on your homework. So you choose the method you like the best, or that best suits the problem. Okay, x plus y is equal to 3, and negative x plus 2y is 6. In blue, I'm going to do graphing. So how do we graph this? Well, the first thing we have to do is solve for y. So for each equation, I'm going to put it in terms of y is equal to something plus x. So for the first equation, you get y is equal to negative x plus 3. Just move the x to the other side. And then for this one, we have to move the x over. So we get x plus 6 is equal to 2y. But let's get rid of this 2. We're going to divide everything by 2. So we get x over 2 plus 3. Okay, now the system is the same as this one here. What I'm going to do is I'm going to make my xy plane, and I'm going to try to graph this. Now you can graph it by hand, and you can also use a graphing calculator. This particular example is really easy to graph by hand. So let's see. For the first line, we have that we go through the point 0, 3. That's the y-intercept. And the slope is up 1, down 1. Sorry, up 1 and to the left 1, or down 1 and to the right 1. So just an idea of what this graph looks like. Something like this. So I'm going to put first equation so we can keep them straight. And then this one also goes through the point 3, and the slope is up 1 over 2. Now let me fix this a little bit, because this point right here is 3, 0. So up 1 over 2 would be somewhere like this. Okay, there's a few problems with my graph. The first problem is the way that I have spread these points out, so these dotted lines, you can see that this is the number 3. So it's like 1, 2, 3, but then I have a big space here. So I'm not evenly spacing my dashes, which makes these lines kind of look like they have the same slope, but they don't have the same slope. So maybe we can draw it just a little bit better. So let's see, 1, 2, 3, 4, and I'm also going to do that on the bottom here. So try to space them evenly. Okay, so for the first equation, we went through 3, and it was up 1 over 1. And we should be going through the x-axis at 3. So somewhere around there. Okay, that's a decent sketch. So that's the first equation. Now let's graph the second one. So we also go through 3, but the slope is up 1 over 2. So I think that looks a little bit better. Okay, we can easily see the point we go through. It is the y-intercept for both of these. The point here is 0, 3. That's the y-intercept. So that is our solution. You can see that these lines only cross at one point. So the solution is the point 0, 3. If you plug that in, you can see that you get a true statement here. If you plug in 0 plus 3, you get 3. You could also plug it on this side. 0 plus 3 is equal to 3. And if you plug in 0, 2 times 3 is 6. So you get a true statement. Now, graphing by hand for this particular example was really easy. Notice that there were some challenges, though, like evenly spacing your tick marks. And if you get something where you have like y is equal to negative x plus 1 over 5 fractions, where it's not so easy to graph, that could cause a problem. And when the two lines cross at some very strange point that looks like halfway between, so let me give you an example of what I mean here. So if we had something like this, let's say our first graph went like this, and then maybe the second graph was really close to this y-intercept, but not exactly. So let's say we went through right here, something like this when we graphed it. And it was really hard to figure out what that point was. It was somewhere, the x value is somewhere between 0, 1, and maybe the y value is a little bit bigger than 3. This can cause problems when you're graphing it by hand. Graphing by hand is not usually a good idea unless these two graphs intersect at a really nice looking point. It's easy to see. If you want to graph something, you should probably do it using a graphing calculator. And we're going to do that with the other examples to see that. So graphing is not, I wouldn't say it's the best way to do this. You're going to have to use a graphing calculator, particularly if you're dealing with fractions. Sometimes the two lines don't cross at a nice point that we can see. Maybe it's far out, it's hard to find. So I wouldn't say that this is the best way to solve a system. However, visually it looks nice and you can get an idea that, oh, they only cross on one point. Okay, so we've done graphing. Now let's try substitution. I'm going to erase some stuff in just a second. For substitution, we're going to start right here at the beginning again. And let's put this in green. We're using substitution. What's going to happen is we're going to get the same answer when we use this method. To use substitution, you pick your favorite variable, x or y. It doesn't matter which one. And you're going to look at one of the equations and you want to solve for one variable, either x or y. It doesn't matter which equation you use. You can use the first equation or the second equation, but you want to choose a variable that's easy to solve for. So for example, to solve for x here, all I would have to do is move the y to the other side. Notice that this is x is equal to 3 minus y. That's all I would have to do. I could also solve for y in this first equation. All I would have to do is move the x to the other side. That's easy. So it doesn't matter which one you use. Down here, let's say you wanted to solve for x. Well, you could do that, but you would have to move the x over here and then move the 6 over here. It's just an extra step. You can do it. It's just one extra step. And to solve for y, you would have to move the x over and then divide by 2. So when you use substitution, always try to solve for a variable that's easy to solve for. Okay, so here I've solved for x. I'm going to go with that. And then the next step is to take that x, which is equal to 3 minus y, and in the second equation, wherever you see an x, which is right here, instead you're going to put 3 minus y. So we're substituting in that 3 minus y in for that x. That's why this method is called substitution. And when we do that, we'll be able to solve for y. So let's do that. So we get negative, because this is negative x, so negative 3 minus y plus 2y is equal to 6. Now notice that this negative is on the outside of x, so we need to send that negative into everything here. Don't just put it in front of that 3. So we get negative 3 plus y plus 2y is equal to 6. So simplifying this, we can move the 3 over. We get 9, and that's equal to 3y. And divide by 3, we get y is equal to 3. So we found one of the variables. To find the other variable, we just take what we found for y and plug it into either equation. Okay, so how about we plug it into the first one? So the first equation is x plus y is equal to 3. So we get x plus 3 is equal to 3. So x is equal to 0. And so we got the point 0, 3, just like we did when we were graphing. Some things that can go wrong with substitution is that when you solve for y is equal to 3, you might plug it into the first equation. If you do that, things are just going to cancel. You won't be able to solve for your variable. Or like if you solve for x, you have x is equal to 3 minus y, and you plug it into here instead of here, then you're going to run into, things are just going to disappear. And that's not what you want. You're always going to solve for a variable in one of the equations and plug it into the other equation. So here I solve for x in the first equation, so I'm plugging it into the second equation. We'll do another example a little bit later so you can see it a little bit better. Now let's try elimination. So I'm going to erase some. Okay, elimination. Elimination is where we add the two equations together to get rid of one of the variables. And we also might multiply one of the equations by a number if the variables don't go away when we originally add the two equations together. So for this example, we have x plus y is equal to 3 and negative x plus 2y is equal to 6. If we add these two, notice what happens to the x. It goes away and we're left with 3y is equal to 9 or y is equal to 3. Now notice that this, at least for me, it seems a lot quicker than the substitution method we used just a minute ago. And then we can use that y is equal to 3 and we can plug it into either one of these equations. Since we plugged it in the first one when we used substitution, let's plug it into the second one just for more practice. I'm going to plug it into here. I get negative x plus 6 is equal to 6, so I get x is equal to 0. So just like before, we got the solution 0, 3. For this particular problem, elimination was the quickest way to solve the system. And that's because we had this x and this negative x, and they canceled really easily when we added the two equations together. So for this particular problem, elimination was the easiest choice. Substitution took a little more time, but that was also an easy choice. And graphing was easy as well, but we had to solve for y in both equations. So it took a little more time than substitution. So I would say elimination was the quickest here, but it's not always going to be the quickest. Let's look at the next problem. Here I have 3x minus 2y is 2, and 5x plus 4y is 1. For this particular problem, I think maybe substitution will be the quickest, but we'll see. We're going to try each one, and I think I'm going to start with substitution this time, and then maybe do graphing and elimination. For substitution, we pick our favorite variable in either one of the equations. Let's see. I think last time we solved for x, So let's solve for y. If you look at both of these equations, if we're going to solve for x, we're going to have to move the part with the y over. So for either one of them, we move y over, and then we have to divide by coefficient. So if we solve for x in the top or the bottom, it doesn't matter which one we choose because it's going to be the same amount of steps. The same thing with solving for y. We would have to move the 3x over or the 5x over and then divide by coefficient. So it really doesn't matter at this point which variable you choose. I'm going to choose y. Let's solve for y in the second equation. So we have 5x plus 4y is equal to 1. So to solve for y, I'm going to move the 5x to the other side and then divide everything by 4. So I get negative 5 over 4x plus 1 over 4. Okay, I'm going to circle this, or I like to put a little rectangle around it so I can see the equation for y easily. Now what I do is that now that I have solved for one of the variables and I solved it in the second equation, this one here, I'm going to plug this into the first equation. So wherever I see a y, I'm going to substitute this in. That way I have an equation that just involves x. So I get 3x minus 2. Here's the y, so I'm going to put negative 5 over 4x plus 1/4 and set that equal to 2. Notice that I just substituted. That's the only thing I changed in this equation. Okay, now let's distribute this negative 2 to everything. We get 3x. Notice that this negative 2, there's a few ways to do this. I'm going to go ahead and distribute it in. So we get plus 10 over 4x plus 2 over, actually this is minus because we have this negative. So it becomes a minus 2 over 4 is equal to 2. And then we're going to simplify that a little bit. So let's divide the 10 and the 4 by 2 and then divide these by 2. Okay, so we have 3x plus 5 over 2x minus 1/2 is equal to 2. Now we can combine these two. To combine them, we have to get the same denominator. So 3 over 1 is the same thing as 6 over 2. So let's write that here. This is 6 over 2. And to add these two together, you're going to get 11x over 2. And then I'm going to move the 1/2 to the other side. This is 2 over 1. So 2 over 1 is the same thing as 4 over 2. So 4 over 2 plus 1/2 is 5 over 2. So we get 11x over 2 is 5 over 2. We need to solve for x, so we're going to multiply both sides by 2. We get 11x is 5, and then x is equal to 5 over 11. So we found the x variable. Now we're going to use that to find y. And what you can do is you can plug it into either one of these equations, or remember that we circled this one here, we can plug it into here to find y because this one's already set for y. It says y is equal to this. So we're just going to plug in that value, this 5 over 11, into here to get y. So let's do that. So y is equal to negative 5 over 4 times 5 over 11 plus 1 over 4. I'll get negative 25 over 44 plus 1 over 4. And to add these, I need to multiply the top and the bottom by 11. So I get 44 over negative 25 plus 11. I believe that is negative 14 over 44. And we can simplify that a little bit. Divide by 2, we get negative 7 over 22. So that's what y is equal to. Let me write it here. Y is equal to negative 7 over 22. So the ordered pair is 5 over 11, negative 7 over 22. Now notice that this problem had a lot of fractions. Okay. If you're not good with fractions, I recommend using a calculator. And I always recommend double checking your answer. So since we found this answer, we need to plug it back into our equations just to see if we got a true statement. If we get something that's not a true statement, then we did some kind of calculation error. So let me erase some of this and so that we can plug this into our original system. Okay, so here's the system. 3x minus 2y is 2 and 5x plus 4y is 1. To double check this answer, I'm going to plug this in for x and this in for y. Because these are fractions and it would eat a lot of time for me to calculate this by hand, I'm going to plug them into a graphing calculator. So I'm going to switch over to my graphing calculator. Here we are. And notice that I've just written 3x minus 2y and 5x plus 4y into these two slots. And what I'm going to do is I'm going to substitute in that x value and that y value in here and see if the graphing calculator gives me 2 for the first one and 1 for the second one. Okay, so let's see what happens. I'm going to put 5 over 11 here, get rid of that x. And instead of y, we had this negative 7 over 22. Oops. Put that right in here. And you can see that I got 2 for this one. Now let's try the second problem. Let's put 5 over 11. And then the other one was negative 7 over 22. And I got 1. So I did get, when I double checked and I plugged these two, this x and this y into each equation, I got a true statement. Because the first one, the 3x minus 2y, that does equal 2. And then the 5x plus 4y, that equals 1. Okay, so let's switch back. Just a second. Okay, and now we're going to try to solve this problem using elimination. Okay, so for elimination, what we need to do is we need to add these two equations together and get rid of one of the variables. So how can we do that? Okay, so let me write down the two equations down here. 3x minus 2y is equal to 2, and 5x plus 4y is equal to 1. If I just add these two together like this, notice I'll get 8x plus 2y is equal to 3. And I did not eliminate one of the variables. The goal is to eliminate one of them. So when I add them together, I only have an x or I only have a y. So to do that, we need to multiply one of these equations or both of these equations by some number so that when we add them, one of the variables goes away. So let me write this equation here again. All right, we want to do the least amount of work. Notice that if I multiply the top equation by 2, I'll get a 6x, a minus 4y, and a 4. That minus 4y, if I add it to this 4y, will disappear. And then I'll have something just involving x. That's what we want to do. We want to get rid of one of the variables, and all I have to do to get rid of the y is multiply this one by a 2. Another option I could do is get rid of this x. But to get rid of this x, there's I could multiply this 3 by 5 over 3. If I do that, I'll get I can multiply by negative 5 over 3 like that. That'll cancel. But then I'm going to be dealing with fractions when I send this one in to everything. And I really don't like dealing with fractions. It's a lot of work. So let's not do that. You could also multiply this equation by a negative 5 and this equation by 3, because on the top you'll get a negative 15 and here you'll get a 15. And so when you add them, you will get 0. You could also multiply this one by a positive 5 and this one by a negative 3. It doesn't matter. But the least amount of work will be multiplying this top equation by 2. And when we multiply by 2, we have to multiply every single thing by 2. So let's do that. Let's move over here. I'll get a 6x, a minus 4y, and a 4. And on the bottom, I have a 5x plus 4y equals 1. Now let's add the two equations. If you do that, you'll get 11x plus 0y is equal to 5, which means x is equal to 5 over 11. And so that was a quick way to find x. Now to find y, we have to substitute that x into one of these equations. So you can go into here or this one, whichever one you want to substitute it in. I think I'm going to just plug it into the first equation. So let's see what happens when we do that. So we have 3x minus 2y is equal to 2. So 3 times 5 over 11 minus 2y is equal to 2. Then this becomes 15 over 11 minus 2y is equal to 2. Move the 15 over 11 to the other side. This is 2 over 1. But 2 over 1 is the same thing as 22 over 11. Just multiplying this by 11, the top and the bottom. So then you can see that we're dealing with fractions, but I mean, that's okay. Let's just keep going. 15, I think that's 7 over 11. Negative 2y equals 7 over 11. So then we get y is equal to negative 7 over 22. I believe that was, yeah, negative 7 over 22 was the y value. So the ordered pair, if you want to put them in terms of ordered pairs, this is the solution to the system. So that is elimination. Now, I don't know if you think that was quicker. I think definitely finding the x part was quicker for this problem. But finding the y took some time. So if you like substitution or elimination, I think maybe an elimination was a little bit easier for this one, but it's up to you. Now let's try graphing. Okay, I'm going to share my graphing calculator. Notice that in the graphing calculator, the first equation I said is the red one is 3x minus 2y is equal to 2. And then the other equation is 5x plus 4y is equal to 1, which is this blue graph here. My graphing calculator allows me to put equations in the standard form. If you're using like a TI-83, you'd actually have to solve for y to plug this in. So that's a little bit of work solving for y, but you should get the same picture of a graph. And notice that if I click right here, the dot, this point here is 0.455 and negative 0.318. Okay, so here we come to a problem where this may be a rounded answer. You definitely don't see it in terms of fractions. And if you use a graphing calculator, if this is like an irrational number or like a fraction like 1 over 3, so 1 over 3 is the same thing as 0.33333 repeating, it might be hard to switch to a fraction form. So if you get some numbers like this with not a clear number here, I would think substitution elimination would be a better method of finding the answer. But notice that the first one, let me write down what we had. 5 over 11, and I think the other one was negative 7 over 22. Now if I click at this point right here, you can see that 0.455. So you see that they're rounding this 0.454545 to 0.455, and then this negative 0.318. You can see that is also a rounded number. So again, it depends on what your homework asks. If they ask you for a rounded number, then just graphing it is fine here. But if they want an exact number would be this fraction, 5 over 11 or negative 7 over 22, not where you're rounding. So I wouldn't think graphing would be a good way to solve this problem if you're looking for exact numbers. Okay, let's go back. All right, so let's move on to the next problem. So we have 3x minus 2y is 0 and 5x plus 10y is 4. I'm going to solve this using, let's do, I guess we can do substitution first and then elimination, and then we're just going to verify it with graphing. So substitution, and then over here, we're going to use elimination. Okay, maybe pause the video and see if you can solve this using substitution. Now, there's an x variable and a y variable. You have to pick which one you want to solve for, and then you want to plug it into the other equation. So I might use a different variable, but you should still get the same answer. So pause the video and see if you can solve this problem using substitution, and then see if we get the same thing. Okay, So what I'm going to do is I'm going to solve. I want to do something that doesn't take a lot of work. I think we could just solve for x in the first equation. So we have 3x minus 2y is equal to 0. So move the y over. So we get 3x is equal to 2y, or x is equal to 2 over 3y. So that's our first step. We solve for a variable. And since I solved for the variable in the first equation, I'm going to plug it into the second equation. So I have 5x plus 10y is 4. So wherever I see an x, I'm going to plug in 2 over 3 plus 10y is equal to 4. And I'm going to show you a little trick here. So we get 10 over 3, that should be a y, sorry, y plus 10y is equal to 4. Now, I don't like fractions. You probably don't either. So a way to get rid of them and not worry about them until the end of the problem is if we multiply by this number down here. I'm going to multiply this whole equation by the number 3. So I'll get 10y plus 30y, because I have to distribute it, is equal to 12. And now I've gotten rid of that fraction until the end. So I get 40y is equal to 12. And now y is equal to 12 over 40. Let's simplify that a little bit. This is y is equal to, I can divide the top and the bottom by 4. So I get 3 over 10. So now I have the y variable. I go back up here. Notice that I circled this. I circled that because I can easily plug this y value into that equation. So y is 3 over 10, and then x is 2/3 of 3 over 10. So the 3's cancel, and I get x is equal to 2 over 10, which is 1/5. Okay, and so the solution, let me write this in red, is 1/5 3 over 10. And we should get the same answer when we use elimination. Okay, so I'm going to erase this. Give me just a second, and then we'll try this problem using elimination. Okay, so to use elimination, I'm going to copy the problem down over here again. And then I ask myself, what variable do I want to get rid of? And what do you think would be the easiest variable to get rid of? Notice that if I just add these two equations together, I won't get rid of anything. But if I multiply the top equation by 5, I'll get a negative 10y. So let's do that. We get 15x minus 10y is equal to 0. And I get 5x plus 10y is equal to 4. Add these two together. We get 20x is equal to 4. So x is 4 over 20, which is the same thing as 1/5 here. X is 1/5. And then we just need to pick one of the equations, either one. And I would start before I multiplied anything, maybe the first one. Plug this 1/5 in and see if we get 3 over 10. So we have 3x minus 2y is equal to 0. So 3 times 1/5 minus 2y is equal to 0. So I get 3 over 5 minus 2y is equal to 0. Again, let's do that trick. Well, actually, we don't have to do much if we keep the fraction. Let's move the 3/5 over. So negative 2y is negative 3 over 5, and then divide by negative 2. Y is equal to negative 3 over negative 10, or just 3 over 10. Is that what we got over here? Let's see. Yeah, that is the y value. Okay, so we use elimination for this problem, and we got the same answer. Now again, when you're doing these problems for homework, you only have to choose one way to solve it. So you could just use elimination, or you could just use substitution. I just want you to see the different ways to do it. And also, if you only use one way, I recommend you double check by plugging that 1/5 and that 3/10 and making sure you get 0 in this first equation and 4 in the second equation. Now we can graph this. I'm going to put it in the graphing calculator and we're going to check that we only cross at this point. Okay, so you can see that the red line is 3x minus 2y is 0. The blue line is 5x plus 10y is 4. I also put in the fraction 1/5 here. That is 0.2. And 3 over 10 is 0.3. So let's see where they cross. They cross at 0.2, 0.3. And visually, we can see that we only intersect at one particular point. Okay, now let's go back and look at the next problem. So here's problem number 4. What we're going to do is we're going to solve it by using substitution or elimination. What I would like you to do is pick one, either substitution or elimination, and then check and see if you get the same answer I get. So choose either one and just do it using one type. And I'm going to put substitution elimination, both methods, on the screen. So pause the video and choose the method you like, and then see if you get the same answer I get. Okay, let me show you the method using substitution. Here, I noticed that to solve for y, all I had to do for the second equation is move y to the other side and then move 7 back on this side. And then I flipped it. So you can see that y is equal to 3x minus 7. So I solved for y in the second equation. I had to plug it into the first equation wherever I see a y. And that's what I did on this side here. So you can see here's the y, so I put in 3x minus 7. Then what you see here is me just trying to simplify this. I added the 2x and the 12x, and then I moved the 28 to the other side and solved for x. And I ended up getting x is 43 over 21. Then, remembering that I had this y is equal to 3x minus 7, I used that and I plugged in the x value here and then solved for y, and I got the answer 43 over 21 for x and negative 6 over 7 for y. How I'm going to double check this is by graphing it. I'm just going to use my graphing calculator. So let me show you the graph. And you can see here are our two lines. And you can see that this is the point where we cross the red and the blue lines. So the equations are given here. And I also put these numbers in the calculator just to see that the fractions are have the same decimals as this. And you can see they do. Let me go back. And now I'm going to show you how to solve this using elimination. Okay, for the elimination method, here I put the answer that we found with substitution. I decided to get rid of the variable x. Now this problem is set up for you to get rid of the variable y because all you have to do is multiply the bottom equation by 4. However, I wanted to show you how to get rid of a different variable. So here I'm going to get rid of the variable x. So what I did was I multiplied the top equation by 3 and the bottom equation by negative 2. You can see that I did that right here. And when I multiplied the top equation by 3, I got 6x plus 12y is 2, and the bottom one I got negative 6x plus 2y is negative 14. Then if we add these two together, we get rid of that x, and then I was able to get y is equal to negative 6 over 7, just as expected. Then I took this value and I plugged into the first equation. So it doesn't matter which equation you plug it into. Again, here's the original two equations. The first or the second one, I just went with the first one. So I plugged that into the first equation here, and you can see I plugged it in right here for the y, and then I simplified, and here I try to get rid of the fractions, so I multiplied everything by 21, and I ended up with the same answer. So if you want to look at this more closely, maybe pause the video. I'm going to move up a little bit and see if you can understand how I got to this answer here. Okay, so we have solved this fourth problem. There's two more problems I want to look at. And these two problems involve when we don't get just one solution or we have no solutions. So let's look at them. For problem number 5, I have x minus 2y is 9 and 11x minus 22y is 99. And for problem 6, these are very similar. I got x minus 2y is 9 and 11x minus 22y is 8. So for one of these problems, you're going to get infinite solutions, and the other problem, you're going to get no solution. Can you see which one is infinite solutions and which one is no solution? Well, the top one is infinite solutions. And why is that? Notice that if we multiply the top equation by 11, we're going to get the bottom equation. So these are actually the same line. So these two lines are overlapping. Okay, so what would happen if you didn't notice this right off the bat? You just saw that these two, you wanted to use like substitution or elimination. Well, let's see what happens. I'm going to use, let's say, substitution for this first equation. Let's put some space in here. So this problem is nicely set up for substitution because all I have to do is I can solve for x by moving this 2y to the other side. So x is equal to 9 plus 2y. And then I can just plug this x into here. So I get 11 times 9 plus 2y minus 22y is 99. So we get 99 plus 22y minus 22y is 99. And notice that these go away and we get that 99 is 99. If you ever run into this situation where the variables disappear and you get a number is equal to that same number, it could be any number here as long as that same number is on this side, then you have infinite solutions. So you got a true statement, any value you plug in for x, the y will depend on that value. The dependency relation is by this equation of this line, but you're going to have infinite solutions. So anything you choose for this one, for example, if I plug in 9 here and 0 here, I'll get 9. So if I plug in 9 here and 0 here, I'll also get 99. If I plug in, let's say, 1, actually, let's not, yeah, 1's fine, and -4 into here, you see that we get 9, and if you plug it into here, you'll also get 99. So you're going to see that you're going to have infinite solutions, and those solutions depend on the equation of this line here. So that's why it was a dependent system. So what's going to happen with substitution and what's going to happen with elimination, I'll show you with elimination as well. You're going to get that a number is equal to another number, and that those two numbers have to be the same. So for elimination, let's erase this. Well, what would happen? Let's go back to this original equation here. Well, I would notice, oh, let me just multiply the top equation by, to get rid of this x, by -11. So I'll get -11x plus 22y equals -99. And then on the bottom, I have 11x minus 22y is 99. And then we add them together, we get 0 is equal to 0, which is a true statement. The x and the y's went away. So that tells you you have infinite solutions. Now for the bottom problem, this one here, you're going to have no solution. And the reason for this is, notice that if we multiply this by 11, we get this here, but this number is not 99. So these lines are going to have the same slope, but different y-intercepts. So let's see what happens when we got no solution. Okay, so if I solve for one of the variables, again, let's solve for x. X is equal to 9 plus 2y. Plug that in here, we get 11. 9 plus 2y minus 22y is 8. You'll see that you get 99 plus 22y minus 22y is 8. So you get that 99 is equal to 8. That is a false statement. When your variables go away and you get something that's false, then you have no solution. So that was using the substitution method. You could also use elimination and you'll see that you'll get a false statement as well. Because again, if you multiply, let's say the top one by -11, and then leave the bottom one alone and add them, you'll get 0 is equal to negative 91, which is a false statement. So you can see that you'll have no solution.